All right, guys, this is a class activity on limits and continuity. I am going to write the definitions in here, and I highly recommend if you, we've done this already with piecewise functions, to take a minute and try to fill out this chart on your own. And I can even go through 9, and then maybe you pause and try to do x equals 4 and x equals 3 and so on, because the more you can do on your own and then just kind of guess and check is going to be better. F of C is defined. That is a very specific coordinate that they're looking at. The limit of f of x as x approaches C exists or does not exist. And that's how we're going to describe as x approaches C. And then the limit, and you'll understand what I mean here in just a second. The limit of f of x as x approaches C is equal to f of C. And this is going to be more of from the left and the right. So find the function value if it exists for given x value. So at x equals 9, our y value is 3.5. Okay, find the left-hand limit. So at 9, coming from the left, the x value is 3.5 as well. We are going towards 3.5. From the right, there is nothing. So this does not exist. Find the general limit. So because these two do not match, this one does not exist either. And is f of x continuous through x equals 9? No, it is not. There is a point at x equals 9, but it does not continue from left to right. All right, x equals 4. What is our y value at x equals 4? It does not exist because there's an asymptote at x equals 4. It looks like we've got some infinite discontinuity there. All right, so because of that, find the left-hand limit. On the left side of x equals 4, we never even approach anything, so this does not exist. Finding the right-hand limit. So from the right, we are approaching x equals 4, but it is going up towards infinity. So this is going to be probably the only thing that actually has a value at x equals 4. Find the general limit. So because these do not match, this does not exist. And then, is it continuous? Definitely not. There's discontinuity there, so it is completely just not continuous at all. All right, at x equals 3, our y value is 9. From the left, we're approaching 9. From the right, this does not exist. We're not approaching. There is only a value here, and that's because of the asymptote that's there. Find the general limit. So because these two do not match, this does not exist. And then, are we continuous at x equals 3? No, we are not. Okay, and again, feel free to pause at some point if you're starting to get the hang of it, and fill this out, and then check your answers with mine. All right, so at x equals 0, our value is 6. From the left, we're approaching 6. From the right, we're approaching 6. So our value is 6 for the general limit. And then, is f of x continuous here? Yes, it is. It actually, from left to right, is continuous through x equals 0. All right, at x equals -3. Our value here is going to be -6. From the left, we're approaching +5. From the right, we're approaching +5. Find the general limit. This is still 5 because these two are equal, but is it continuous? No, because there is a removable point. All right, at x equals -5, our value is -2. From the left, it is -2. From the right, we have to come up here, it is +7. So we already know that that means that this does not exist. And is it continuous? No, we have a jump. All right, that is part 1 of limits and continuity.